Hey guys, so today you and I are going to talk about architecture. So let's get into it. So the question in question was, hi Frederick, how would I lay out my software architecture before I code if the requirements change every day? That is a pretty easy one actually. And I have given you this answer many times before in my little videos that I make. It comes down to my favorite topic, modularization and writing disposable code. That's the thing that you should do, in my opinion, at the very least. And then, there's this other thing that I've said 100 times. You have to understand the problem that you're dealing with. So let me explain that a little bit. So the analogy that I usually make to people when I talk about architecture and I talk about sort of fundamentally understanding how to create, and this is especially true in front end in my opinion at the very least. Let's take this over to React for those of you who do React. So one of the biggest beginner mistakes that I see with people who do React, it doesn't have to be React, but it's basically any of the visual components, libraries and frameworks that you have out there. It's the same principle, is that a beginner will create a page level component for the whole page. And then they will create something maybe like a header section, maybe something like a body section, and something like a footer. And some people just put basically the page, like all of the HTML and so forth that they need to style to create the page, in that page component. Now, what they have in essence done is to create the equivalent of a God class in the backend world. They have chunked their architecture, quote unquote, of the page to a chunk that is so big that it actually is very difficult for you to change that specification, change the structure of this page over time. It's a very big abstraction, if that makes sense. And so the first thing that I usually coach people with when I'm teaching them how to do this in a better way is to start with the leaf of the problem. In other words, instead of creating the whole page, understand that you have certain segments of the page and you have certain specific elements on the page. It's better for you to start working with the elements on the page, create components for those elements, make them work according to specifications, so say a field or a button or something like that, and then create these smaller building blocks. In other words, you don't start at the top of like you don't go macro, you go micro first. Create each of these smaller components first, compose them together to create the next bigger component, and then the next is if you have take boxes. If you have a descending size of box sizes, then you take the smallest box first, put that in the slightly larger box, and then you take that larger box, put that in the next one, and so forth until you have a Russian nested doll type of situation. That approach is what I'm talking about when I say you create a modularity where you have a larger component made up of smaller components. Why is this significant? I'm glad you asked. The reason why is because what happens now is that instead of having these sort of coarse, gigantic abstractions in your code, you have an enormous amount of very small components. That basically means that when you have that, you can change that very easily in comparison to how you would have to work if you had a really like because if you design things at the page level, the first thing that usually happens is that you interconnect all of these different elements that are now working. You have one set of specifications and you basically design your whole page to work as that entire page. There's no way for you to pull things out or do things like that, because your perspective is not to create one thing that works really well in isolation and then fits nicely into a larger context. You're just creating something in one gigantic context. It's like having one big super function instead of having many small functions or very smaller abstractions that know how to do one work. Like you're basically breaking the single responsibility principle. That is the thing that usually happens. So when you're designing, even if a requirement changes, it's not that problematic. Imagine having like to make it really simple, imagine if you designed a dashboard of different knobs and dials and things where you're going to control like a reactor or something very complicated. Well, you have thousands of those things because you need to have very, very granular control over each thing that is going on. That's a big difference in terms of design. Complexity wise, like, you know, the amount of buttons and dials you have is very high, but that's much more useful for you when you're in an environment where things change all the time and you need to tweak things. It's like just being able to dial, rotate some knobs to get the thing that you want, as opposed to just having one big button every single time, because many times that's not going to be enough. And that's how you should design your system. It's the idea behind, like, that's the same principle behind microservices, for example, because when you have a very big monolith, it is in general more difficult for you to scale and make changes to that big system than it is to, say, do it for a very small system. And so when requirements change all the time, you should account for that. And when you have, as I said, all these tiny little dials and knobs, or like these small modules and so forth, it becomes fairly easy for you to spot which part you need to switch out, what you might have to, like, you create a new module for, or how you might have to tweak something and so forth. So because you've basically given yourself the full control of changing one little piece of the specification, because it's very rare that, you know, they're gonna, when you say requirement change, it's not like they're gonna tell you on day one, oh, you're gonna build a web shop that sells, I don't know, clothes, and then the next day they go, no, we're actually going to sell cars. That's not the thing that usually happens. What usually happens is that specific things about the overall, like the general design or the general architecture are going to change. And if you don't account for that in your code or your setup, that is the thing that usually makes problems for you, because basically you know that if you start coding and you chunk too much, your abstraction basically is wrong or it's too coarse, it becomes a problem for you to change the specification later on, because basically your logic is so tightly coupled or nested into a context that is too big for the thing you want to do. And now you have to change a lot of code, or you have to change a very large set of logic in order to just get at the thing that you really want to control. And that goes away immediately if you start leaf first. Start with a small abstraction, create that first, and build upon it so that you go, like, from the smallest thing up to the largest thing, instead of the reverse. So what I want you to take away from this is that the way that I suggest that you handle architecture in an environment where requirements change all the time, it's actually fairly simple. You have to understand the problem that you are solving first and foremost. Basically, that means that you need to understand what type of system are you creating. The second thing is that you need to understand how to keep things loosely coupled, or how to, as I like to call it, write disposable code. Modularize the things and make sure that you know how to create good abstractions. Because as in my mental picture, it is better for you to have a dashboard of many types of levers and dials and buttons and things like that. You can microcontrol everything that you want, instead of having one big button, like one, as I was saying, if you design a React component or like a visual page, like one gigantic entity, that becomes a nightmare to maintain and update, because it's designed as one gigantic system instead of a system composed of many smaller systems. Because you can create a small UI component that is going to fill your use case really, really well. Use that in a form or something like that, and then reuse that form at a higher level. It's all about understanding how to create good abstractions and modularize your components, so that if you, for example, with my form here, if you need to change the way the fields behave but not the drop downs and stuff like that, it becomes very easy for you to do that, because you have already an abstraction or a module for just the fields. You can control just that part, instead of having to redo basically the whole way that your flow of logic works on the page level, because you wrote everything so that everything about your form exists in this gigantic superstructure. It's the same reason why we have the single responsibility principle. It's the same reason why the backend developers will tell you that God classes are generally a bad thing. And it's the same thing where I will tell you that a monolithic application will, in the beginning of things, usually start out very well, really simple and easy. But the problem is that if you structure it incorrectly, just as with my page example, it becomes a nightmare to maintain, because you can't really microcontrol the parts that you need to touch without having to change the overall thing that you are dealing with. Have a great day.